What is a planet without a sun? Is it merely a dead rock, cast adrift in the endless frozen night, condemned to an eternity of solitude? Or is it something far more profound, a cosmic refugee, carrying the frozen memory of its violent birth, on an eternal journey through the boundless void? For generations, our understanding of the cosmos has been a comforting, familiar narrative, one of cozy solar systems, each a neat, self-contained family of worlds, orbiting a brilliant, life-giving parent star. We look up at our own sun, a beacon of warmth and light, and naturally, we assume this stable, star-centric existence is the universe's default setting. But what if that cherished picture, that intimate portrait of planetary life, is just one small scene in an infinitely larger, far more chaotic, and deeply mysterious cosmic drama? Today, with the insights gleaned from humanity's most advanced observatories and groundbreaking theoretical physics, we invite you to challenge that fundamental perception. We ask you to gaze upon a galaxy not as a collection of stable, sun-bound families, but as a vast, teeming diaspora, a place where the loneliest, most numerous travelers are the planets themselves, billions upon billions of them, not gravitationally bound to any star, cast out from their stellar nurseries, condemned to wander the interstellar darkness forever. These are the rogue planets, the orphan worlds, worlds without a sun, without a traditional home, yet pregnant with a haunting, improbable possibility. Imagine, if you will, the sheer mind-boggling scale of this galactic truth. We're not talking about a few dozen cosmic anomalies. Estimates for the number of rogue planets in our Milky Way alone vary widely, from billions to potentially trillions, with some models even suggesting they could outnumber the stars themselves by a significant margin. Think of it. For every twinkling star you see in the night sky, for every distant sun that offers warmth and light to its own family of worlds, there might be countless unseen planets, silent and cold, drifting through the galactic abyss. These are not merely dead rocks. They are cosmic refugees, forever disconnected from the warmth of a parent star, carrying the echoes of their violent birth through an eternal night. How, you might ask, does a world lose its sun? The story often begins in the chaotic, violent youth of a solar system. Picture a nascent stellar nursery, a swirling, turbulent disk of gas and dust, where planets are still forming, jostling for position in a cosmic mosh pit. It's a game of gravitational billiards on an unimaginable scale, a turbulent ballet of creation and destruction. Massive gas giants, still migrating through their early systems, can act like cosmic bullies, their immense gravity flinging smaller, Earth-like worlds out of the system entirely, into the permanent night, ripped from the only home they've ever known. These worlds are condemned to an eternal, solitary voyage through the cold vacuum. Other rogue planets, often called sub-brown dwarfs, might never have known a star at all, forming in isolation from the direct collapse of gas clouds. Much like a star, but without enough mass to ignite nuclear fusion. But how do we find something that doesn't shine? How do you detect a dark, cold planet, smaller than a star, lost in the vast blackness between stars? It's like trying to spot a ghost in a haunted house, almost impossible with traditional telescopes. Yet, humanity, with its insatiable curiosity and ingenuity, has found a way. It's a sophisticated cosmic ghost hunting technique called gravitational microlensing, a method pioneered by projects like the Optical Gravitational Lensing Experiment, or OGLE, a Polish astronomical project launched in 1992. A rogue planet, though unseen and emitting no light of its own, still possesses gravity, and that gravity can briefly, subtly warp the fabric of space-time, acting like a natural lens. As the rogue planet passes directly in front of a more distant background star, its gravity briefly magnifies and brightens the star's light, sometimes even bending it into a perfect Einstein ring, a glowing halo that fleetingly betrays the ghost planet's presence. It's a fleeting whisper in the cosmic silence, a momentary flash of light that lasts for mere hours or even minutes, providing the only clue to an invisible world. In 2020, astronomers announced the discovery of OGL 2016 BLG 1928, the first compelling candidate for an Earth-mass rogue planet, detected via an exceptionally short microlensing event lasting only 41.5 minutes. A testament to its small mass and the incredible precision of these observations. This brings us to a profound aha moment, one that fundamentally reshapes our entire understanding of planetary existence. The stable solar system we call home, with its planets locked in graceful, predictable orbits around a life-giving star, might not be the galaxy's norm. In fact, solitude, eternal wandering, might be the more common fate for planets in this vast universe. But here's where the story takes an even more astonishing, mind-bending turn. These weren't necessarily barren husks. Imagine a large rogue planet, perhaps many times the mass of Earth, cloaked in a thick, insulating hydrogen atmosphere. Deep beneath that crushing dark sky, could geothermal heat from the planet's core, combined with immense atmospheric pressure, maintain oceans of liquid water on its surface? Could life, robust and vibrant, thrive in an eternal twilight, never knowing the warmth of a sun, nourished by glowing hydrothermal vents, much like the extremophile ecosystems found in Earth's own deep-sea trenches? This isn't science fiction anymore. It's a real scientific hypothesis, first theorized by planetary scientist David J. Stevenson in a foundational 1998 paper, suggesting an entirely new paradigm for habitability, even in the absence of starlight. And what about rogue moons? A large gas giant rogue planet could itself harbor moons, kept warm by the powerful tidal forces of their parent rogue, creating another potential cradle for life, similar to Jupiter's moon Europa in our own solar system. It's a staggering thought, isn't it? To think that life could exist in such an alien environment, a testament to the universe's boundless creativity and resilience. We stand on the precipice of a new era of discovery. Missions like NASA's upcoming Nancy Grace Roman Space Telescope, set to launch by May 2027, are expected to be 10 times more sensitive than current ground-based surveys, poised to discover hundreds, even thousands, of these Earth-mass rogue planets, moving them from theoretical curiosities to observable realities. The European Space Agency's Euclid telescope has already, in its first scientific results in 2024, identified dozens of new rogue planet candidates in the Orion Nebula, demonstrating the power of these new wide-field space telescopes. And the James Webb Space Telescope has stunned us even further with the unexpected discovery of Jupiter mass binary objects, or jumbos. 42 pairs of rogue planets, each between 0.7 and 13 times the mass of Jupiter, freely floating in the Orion Nebula and orbiting each other. These paired-up orphan worlds defy our current understanding of how anything forms in the cosmos, posing a profound new mystery. The galaxy, it turns out, is far stranger, far more populous, and far more mysterious than we ever dared to imagine. You've glimpsed the bewildering truth. Our cosmos is not merely a collection of stable, sun-warmed families, but a vast, chaotic diaspora, teeming with worlds that wander alone. We've discovered their silent presence, glimpsed their numbers, and even found them in strange paired dances in the dark, defying our deepest assumptions about how the universe works. You've seen how the Euclid telescope in its first scientific results in 2024, identified dozens of new rogue planet candidates in the Orion Nebula, showcasing the power of these new wide-field space telescopes. And the James Webb Space Telescope stunned us further with the unexpected discovery of Jupiter mass binary objects, or JUMBOs, 42 pairs of rogue planets, each between 0.7 and 13 times the mass of Jupiter, freely floating in the Orion Nebula and orbiting each other. These paired-up orphan worlds defy our current understanding of how anything forms in the cosmos, posing a profound new mystery. But the deeper question remains: how does a world become an orphan? How does a planet lose its sun, its home, its very purpose, to embark on an eternal journey through the interstellar void? The answer, perhaps surprisingly, lies in the very beginnings of every solar system. A time not of serene birth, but of unimaginable violence and cosmic upheaval. Forget the tidy, elegant orbits you learned about in school, the serene dance of worlds around a star. Imagine, instead, a cosmic arena, a swirling maelstrom of gas and dust, where nascent planets are not gently placed into position, but are locked in a brutal gravitational struggle for survival. This is Act 1 of our story: How to Lose a World. Picture, if you will, the early days of our own solar system, or any star system still finding its footing. The star at its heart has just ignited, a beacon in the darkness. But around it, chaos reigns. Swarms of planetesimals, the very building blocks of worlds, are crashing together, merging, growing. But this isn't a gentle assembly line. It's a demolition derby on an astronomical scale, a crucible of creation and destruction. Out of this turbulent nursery, giants begin to emerge. Massive gas planets, perhaps dozens of times the mass of Earth, begin to sweep through the protoplanetary disk, their immense gravity carving paths, gathering material, and, crucially, influencing everything around them. This is where the game of cosmic billiards truly begins. Imagine a vast pool table, but instead of neatly arranged balls, you have planets, some small and rocky, like our Earth, others gargantuan gas giants, all moving at breakneck speeds, their paths determined not by a cue stick, but by the invisible, irresistible pull of gravity. As these colossal planets migrate inward and outward, their gravitational fields become like immense, unseen hands, batting smaller worlds around with ruthless indifference. Think of a nascent Jupiter, perhaps many times larger and more energetic than the one we know today, still forming, still gathering mass, spiraling inward towards its star. Its path cuts through the nascent orbits of smaller inner planets. As it passes, its colossal gravitational influence doesn't just nudge these worlds, it can utterly destabilize them. One moment, a young, rocky world, perhaps still molten, is finding its footing, slowly solidifying, dreaming of a future bathed in starlight. The next, it's caught in the gravitational wake of a behemoth. You can almost visualize it, a high-fidelity, slow-motion simulation of a Jupiter-sized planet, migrating inward, its gravity flinging a smaller, Earth-like world out of the system into the void. The interaction is brutal, a cosmic sucker punch. The larger planet acts as a colossal cue ball, its immense mass generating such a powerful gravitational slingshot that the smaller world is accelerated to escape velocity. It's a violent, one-sided game, with stakes higher than anything we can truly comprehend. The smaller planet doesn't stand a chance. Its nascent orbit is twisted, stretched, and finally broken. With a final crushing tug, it is flung, not just out of orbit, but out of the entire system. It is a moment of profound cosmic tragedy. A planet's birthright of starlight, ripped away in an instant? You see, the universe is full of mysteries, and few are as profound as the unseen. We left off asking how you find a world that emits no light, reflects no light, and offers no gravitational pull strong enough to easily detect. How do you hunt for something that is, by its very nature, invisible? That question leads us directly to a deeper understanding of what these worlds truly are, before we can even begin to unravel how we might detect them. Because not all cosmic wanderers are the same, and their origins paint a poignant picture of their solitary existence, challenging our fundamental perception of the cosmos itself. For so long, our model of the cosmos has been one of cozy solar systems, a collection of stable families, each planet orbiting its nurturing star. It's a familiar, comforting picture. But as we peer deeper into the cosmic ocean, a new, startling truth emerges. The galaxy is not just an orderly collection of star systems. It is a vast diaspora, teeming with perhaps billions, even trillions of worlds that have no sun to call their own. These are the rogue planets, the free-floating interstellar nomads that wander the cold, dark void. And their stories are as varied as they are lonely, forcing us to ask, what is a planet without a sun? Is it just a dead rock? Or is it a refugee, carrying the frozen memory of its birth, on an eternal journey through the void? When we speak of rogue planets, we're talking about worlds not gravitationally bound to any star. But how does a planet come to be in such a desolate, sunless state? It turns out there are two primary pathways to this profound solitude, like two distinct branches on a cosmic family tree, each revealing a different kind of cosmic loneliness. First, there are the orphans. These are the worlds that were born into a stellar family, nurtured by a parent star, bathed in its formative light. But their youth, my friends, was a violent, chaotic drama. Picture a nascent solar system, a maelstrom of gas and dust, with young, ambitious planets forming and jostling for position. It's a ruthless game of cosmic billiards, where gravitational instabilities run rampant, and survival is far from guaranteed. Imagine a Jupiter-sized planet, perhaps a gas giant many times the mass of our own, migrating inward, its immense gravity acting like a colossal slingshot. In this cosmic dance of giants, it flings a smaller, perhaps Earth-like world out of its orbit and into the eternal night. These are the exiles, the refugees, cast out from their homes, carrying the frozen memory of their birth, on an eternal journey through the void. They are the planets that lost their sun, victims of the brutal formative years of a planetary system, forced into a life of ceaseless wandering. This violent ejection process challenges our traditional models of planet formation, revealing that planetary systems are often far more chaotic and dynamic in their youth than we once imagined. The very idea suggests that our own solar system, in its relatively tranquil maturity, might be an exception rather than the rule, and that countless worlds are born only to be violently cast aside. Then, there are the hermits. These worlds never knew the warmth of a sun, because they were never part of a solar system to begin with. Instead, they formed in isolation, directly from the collapse of a gas cloud, much like stars do, but without gathering enough mass to ignite nuclear fusion. They are, in essence, failed stars, or what scientists sometimes call sub-brown dwarfs, born alone in the dark, in the quiet depths of interstellar nurseries. They are the true solitaries of the galaxy, never having a family to begin with. Their existence adds another layer of profound nuance to the concept of a rogue planet, suggesting that solitude can be an inherent state, not just a consequence of loss. Consider the recent, mind-bending discoveries from the James Webb Space Telescope in the Orion Nebula, which have offered us a tantalizing glimpse into these solitary births. Astronomers have identified dozens of Jupiter-mass binary objects, pairs of rogue planets, each between 0.7 and 13 times the mass of Jupiter, orbiting each other in the vast emptiness. These jumbios defy easy explanation, challenging our current formation theories. Did they form together in isolation? Two hermits finding solace in each other's cold embrace, never knowing a star? Or were they ejected as a pair from a distant, unknown stellar family, a cosmic couple adrift? We've even observed young rogue planets, like Cha 110776DOI6, caught in a massive growth spurt, accreting material at a staggering 6 billion tons per second, a process traditionally associated more with star formation than planet formation. This hints at the hermit origin, a world building itself in the darkness, never knowing a star, embodying a unique form of cosmic self-reliance. So when we talk about these billions of orphan worlds wandering the galaxy, it's crucial to understand this distinction, this profound difference in their genesis. On one branch of our cosmic family tree, we have the orphans, those cast out, the exiles violently ejected from their stellar homes, forever scarred by their turbulent youth. On the other, we find the hermits, those born into solitude, never knowing the gravitational embrace of a sun, their existence a testament to the universe's ability to forge worlds in the deepest dark. This is our aha moment. Not all wanderers are exiles. Some were simply born alone, adding a new poignant layer to their solitary existence. It reshapes our understanding of what it means to be a planet, challenging the very definition we once held so dear. Is a planet defined solely by its relationship to a star, or by its own inherent potential, its own internal fire? They are a profound paradigm shift in how we perceive our galaxy. Not just an orderly collection of star systems, but a vast dynamic arena where solitude is a common fate for worlds, perhaps even the dominant one. The sheer numbers, with some models suggesting they could outnumber stars by a significant margin, are difficult to fully grasp. Yet they paint a picture of a cosmos far more chaotic and wondrous than we ever imagined. The early studies by collaborations like MOA and OGLE, pioneered by figures like Professor Andrei Udalski, were instrumental in shifting our perspective, providing the first compelling evidence that these Jupiter-mass rogue planets could be incredibly common, possibly outnumbering main-sequence stars themselves. This research has shown us that the galaxy is truly a vast diaspora of wandering worlds. It's a staggering thought, a profound re-evaluation of our place in the universe. Understanding these origins is the first crucial step in truly appreciating the scale of the challenge that lies ahead. Because whether orphaned or born solitary, whether carrying the memory of a lost sun or knowing only the deep dark, these worlds are incredibly difficult to find. They are the ghosts of the cosmos, leaving behind only the faintest whispers of their passage. And in our next act, we'll delve into the ingenious scientific methods, the cosmic detective work that allows us to find the unseen. We'll explore how astronomers are hunting these dark, cold worlds, one fleeting signal at a time, transforming theory into tangible discovery. You just heard how our galaxy, far from being a collection of stable, star-centered families, might actually be a vast, sprawling diaspora, a cosmic tapestry woven with perhaps billions of orphan worlds. Worlds that were flung from their homes in the violent ballet of nascent solar systems, or perhaps formed in the cold dark, knowing no sun. But the question, the profound challenge remains. How do you find something that doesn't shine? How do you hunt for ghosts in the infinite blackness of space? Imagine for a moment that you're adrift in a boundless, starless ocean, and you're searching for a single dark, submerged object. It emits no light, reflects no light. It's a phantom. These aren't stars, blazing with their own nuclear fire. They aren't planets reflecting the gentle glow of a sun. They are worlds of pure shadow, wandering through the interstellar void, perfectly camouflaged against the cosmic dark. The answer, as is so often the case in the universe, comes from one of the most elegant and profound insights of the 20th century, Albert Einstein's theory of general relativity. It tells us that gravity isn't just a force pulling objects together. It's a warping of the very fabric of space-time itself. Massive objects, like stars and planets, create dimples in this cosmic fabric, and anything passing through those dimples, including light, will follow the curve. This isn't just abstract physics, it's the ingenious key to finding the invisible. Think of it like this. Picture a distant candle flame. The rogue planet is our wine glass. Its immense unseen gravity is the lens. And the distant candle? That's a star. As the dark, wandering rogue planet passes almost perfectly in front of that background star, an alignment so precise, it's like hitting a cosmic bullseye. Its gravity warps the space-time around it. The light from the background star, instead of traveling in a straight line, is bent and focused by the planet's gravitational field. For a fleeting moment, the star appears to brighten, its light magnified by the invisible world passing between us and it. This phenomenon is called gravitational microlensing. And if the alignment is truly perfect, we might even glimpse a fleeting, shimmering Einstein ring, a luminous halo of distorted starlight that momentarily confirms the presence of the hidden mass. This is the extraordinary ingenuity of the method. By watching how gravity bends light, we have learned how to find the invisible. This cosmic detective work began in earnest with pioneering projects like the Optical Gravitational Lensing Experiment, or OGL, a Polish astronomical survey launched in 1992 and led by the visionary professor Andrzej Udalski. His team at the University of Warsaw developed the sophisticated techniques needed to continuously monitor millions of stars in the dense star fields of the Milky Way's bulge, patiently waiting for these incredibly rare, fleeting microlensing events. It was a monumental undertaking, a testament to human perseverance and scientific curiosity, and their patience paid off. The OGL collaboration, alongside the microlensing observations in Astrophysics, MOA collaboration, began to gather the first compelling evidence of a vast population of these free-floating worlds. In 2011, a landmark study from these teams suggested that Jupiter-mass rogue planets could be astonishingly common. The hunt became even more precise, and in 2020, the OGL astronomers made a truly groundbreaking announcement: the discovery of OGL 2016 BLG 1928. This wasn't just another rogue planet. This was the strongest candidate yet for an Earth-mass rogue planet. The microlensing event was incredibly short, lasting only 41.5 minutes. This incredibly brief flash of light indicated an incredibly small lensing object, leading scientists to conclude it was likely a world with a mass similar to our own, or perhaps even Mars. Think of the odds, the precision required for that tiny, dark world to pass perfectly in front of a distant star. The implications were profound. If we could detect an Earth-mass rogue planet, even a single one, through such an ephemeral event, then the galaxy must truly be overflowing with them. The scale is almost incomprehensible, with estimates for the number of rogue planets in the Milky Way varying from billions to potentially trillions, and the future promises to unveil even more of these cosmic nomads. NASA's upcoming Nancy Grace Roman Space Telescope, set to launch by May 2027, is designed to be 10 times more sensitive than current ground-based surveys. It's expected to revolutionize our understanding of rogue planets. The European Space Agency's Euclid telescope, launched in 2023, has already begun contributing to this revolution, identifying dozens of new rogue planet candidates in the Orion Nebula in its initial scientific results from 2024, ushering in a new era of wide-field surveys for these elusive objects. It's a staggering thought, isn't it? That we, with our fragile instruments and insatiable curiosity, have developed the means to perceive the truly invisible. We have transformed the theoretical into the tangible, proving that these orphan worlds are not just figments of our imagination, but a ubiquitous, if hidden, reality of the cosmos. But the discovery of these ghost worlds opens an even more profound question. Could these solitary wanderers, these refugees of the cosmos, harbor something utterly unexpected? Could they, against all odds, be cradles of life, thriving in eternal darkness, under skies that have never known a star? The notion of a planet, ripped from its stellar embrace, wandering the cosmos in eternal night, is already a profound challenge to our understanding. But the deeper question, the one that truly stirs the imagination, remains. Could these solitary travelers be more than just frozen husks? Imagine for a moment the galaxy as a vast, ancient library, its shelves laden with untold volumes of knowledge. Most of these books are illuminated by the steady glow of stars, their stories clearly visible. But what if there were entire sections hidden in shadow? For decades, the idea of planets without suns remained largely theoretical, a mathematical consequence of the violent birth pangs of solar systems. We understood how they might be ejected, these celestial refugees, but seeing them, that was an entirely different matter. But scientists, driven by an insatiable curiosity, rarely accept impossible as a final answer. They sought a way to detect the unseen, to find these phantom worlds that populated the spaces between the stars. Their solution arrived in the form of a phenomenon as elegant as it is mind-bending: gravitational microlensing. Think of it like this: space itself is not an empty stage, but a fabric, a vast invisible tapestry woven by gravity. Every object with mass, a star, a galaxy, even a planet, creates a warp or dimple in this fabric. Now, imagine a distant star, millions of light years away, shining its steady light towards us. If, purely by chance, a rogue planet happens to pass directly in front of that star, its gravity will briefly bend and magnify the star's light, acting like a cosmic lens. This is where the human story truly begins, with the optical gravitational lensing experiment, or OGLE. Launched in 1992 by the University of Warsaw, OGLE wasn't just another astronomical project. It was a pioneering survey designed to stare patiently at millions of stars. The OGL team, a dedicated group of astronomers, spent years developing the sophisticated algorithms and observation techniques necessary to sift through petabytes of data, searching for these distinctive tiny flickers. It was painstaking work, a testament to scientific perseverance. Then, in 2020, after decades of patient observation, the OGL collaboration announced a discovery. They had detected a microlensing event, designated OGL 2016 BLG 1928, that was unlike any they had seen before. Its duration was astonishingly short, a mere 41.5 minutes. This was the first compelling candidate for an Earth-mass rogue planet. An entire world, roughly the size of our own, adrift and alone in the vast cosmic ocean, had been revealed by a flicker of light, lasting less than an hour. The discovery profoundly rewrote our understanding of the universe. It moved rogue planets from abstract theory to tangible reality, and it hinted at their sheer abundance. It suggested that the galaxy isn't just populated by stable solar systems, but by perhaps billions, even trillions, of these free-floating objects. The implications of Ogle 2016 BLG 1928 extend far beyond mere numbers. It brought into sharp focus the very real possibility that our galaxy is teeming with Earth-sized worlds, unattached to any star. This isn't just a scientific curiosity, it's a philosophical revelation. But the story doesn't end with detection. Once we know these worlds exist, the natural human impulse is to ask, what are they like? Are they all simply frozen, lifeless spheres? Or could some of them, these cosmic orphans, harbor secrets far more astonishing, far more profound? The scientific community is not content to merely ponder. New missions are already underway. The European Space Agency's Euclid telescope has already begun to identify dozens of new rogue planet candidates. But the true game-changer is expected to be NASA's upcoming Nancy Grace Roman Space Telescope. Imagine then the future, a future where the vague estimates of billions to trillions become precise catalogs, where we move beyond single, fleeting detection events to a comprehensive map of our galactic neighborhood, revealing it to be teeming not just with stars, but with a vibrant, if silent, population of wanderers. And with each new discovery, the questions deepen. Could some of the larger gas giant rogues even possess their own systems of moons? The JWST, in its recent observations, has already thrown a fascinating curveball, discovering dozens of Jupiter-mass binary objects, pairs of rogue planets orbiting each other. The story of Ogle 2069 BLG 1928 is more than just the discovery of a single planet. It's a parable of scientific dedication, a testament to the power of human ingenuity to uncover the hidden truths of the universe. It reminds us that even in the deepest darkness, there are profound stories waiting to be told. The journey from a 41-minute flicker to the potential for life in sunless oceans is a testament to the enduring human spirit of exploration and the boundless enigmas of the cosmos. As we peel back these layers of cosmic mystery, our understanding of what makes a world habitable is being utterly transformed. For so long, our definition of a life-sustaining planet was inextricably linked to the comforting glow of a star, a radiant beacon providing the energy for photosynthesis, warming the surface, and orchestrating the delicate dance of climate. But what if that foundational assumption, deeply ingrained in our terrestrial experience, is not just incomplete, but spectacularly wrong? What if the most profound ingredient for life, liquid water, doesn't require a sun at all? This question, once the sole domain of science fiction, is now a serious scientific hypothesis, reshaping our perception of where life might arise in the universe. Imagine, if you will, a world ejected from its violent birth system, cast into the eternal night, between the stars, a cosmic refugee drifting through the cold, inky blackness, its surface frozen, its fate seemingly sealed in perpetual ice. Yet deep within its heart, a silent furnace burns, radiating heat into its core, a primal warmth left over from its tumultuous formation and continuously replenished by the slow, steady decay of radioactive elements. This is the stage for one of the most astonishing possibilities in astrobiology, an ocean without a sun. The theoretical basis for such an extraordinary scenario was first proposed by planetary scientist David J. Stevenson in a groundbreaking paper in 1998. Dr. Stevenson, a professor at Caltech, dared to challenge the stellar-centric view of habitability, suggesting that a large rogue planet, untethered from any star, could still possess the most vital ingredient for life, liquid water. His hypothesis focused on a specific type of rogue world, one massive enough to retain a thick, dense atmosphere, primarily composed of hydrogen. And this is where the magic, or rather, the physics, truly happens. Picture this planet as a cosmic pressure cooker. The dense hydrogen atmosphere, perhaps hundreds or even thousands of miles thick, acts as an incredibly efficient insulating blanket and a formidable lid. It's not just a thin wisp of gas like Earth's. It's an immense crushing envelope that traps the internal heat emanating from the planet's core. This heat, generated by the residual energy from its chaotic formation and the ongoing radioactive decay of heavy elements within its mantle, would otherwise simply radiate away into the frigid interstellar void. But the thick hydrogen acts as a thermal barrier, preventing this precious warmth from escaping. Furthermore, the sheer pressure exerted by such a massive atmosphere plays a crucial role. Just as a pressure cooker on your stove allows water to boil at a higher temperature, the immense atmospheric pressure on these rogue planets would elevate the boiling point of water significantly. This combination, internal geothermal heat trying to escape, and an incredibly dense atmosphere trapping it and simultaneously keeping water liquid at higher temperatures, creates a delicate but powerful equilibrium. Under these conditions, the surface of a large rogue planet, despite never having felt the warmth of a star, could host vast, deep oceans of liquid water. This is the profound aha moment that shifts our entire paradigm. A sun might not be a prerequisite for life's most essential ingredient. A planet's own heart, if properly insulated, could be enough to create a habitable niche in eternal darkness. It's a staggering thought. So, what would an ocean without a sun be like? Imagine descending through that crushing, hydrogen-rich sky. The light from distant stars, if visible at all, would be warped and diffused. The world below, shrouded in perpetual twilight or absolute blackness. As you plunge deeper, the pressure would build to unimaginable levels, the atmosphere growing denser and hotter. Then perhaps you might break through a shell of high-pressure ice, only to emerge into a vast, unfathomable liquid realm. This global ocean would be perpetually dark, illuminated not by sunlight, but by the faint ethereal glow of bioluminescent organisms, or perhaps by the fiery plumes of hydrothermal vents rising from the ocean floor. Here, life wouldn't rely on photosynthesis, the solar-powered engine that drives most ecosystems on Earth. Instead, it would likely harness chemosynthesis, drawing energy from the chemical reactions occurring around these geothermal vents, much like the incredible ecosystems found in Earth's own deep-sea trenches. The implications are immense. If these sunless oceans can exist, and if life can thrive within them, then the number of potentially habitable worlds in our galaxy explodes. The universe isn't just a handful of Goldilocks planets orbiting their stars. It's a vast cosmic ocean where perhaps billions of orphan worlds could be silently nurturing life in their dark subterranean seas. And it's not just the planets themselves. Some large, gaseous rogue planets could even retain their own moons, kept warm by the powerful tidal forces exerted by their massive parent, creating yet another potential cradle for life, similar to Jupiter's moon Europa, but without a stellar parent. These rogue moons would experience extreme tidal heating, constantly kneading their interiors and generating enough warmth to maintain subsurface oceans. The Nancy Grace Roman Space Telescope, set to launch by May 2027, promises to be a game-changer in this hunt for unseen worlds. With its vastly superior sensitivity, it's expected to discover hundreds, if not thousands, of Earth-mass rogue planets, providing us with a much clearer census of their population. This will move the concept of these orphan worlds from theoretical possibility to observable reality, giving us concrete targets for future study. The Euclid Space Telescope, already providing its first scientific results in 2024, has also begun to identify numerous new rogue planet candidates in the Orion Nebula, further solidifying their omnipresence. The universe, it seems, is far stranger and more wondrous than we ever dared to imagine. It is not merely a collection of stable, star-centered families, but a dynamic, chaotic, and incredibly fertile environment where life might find a foothold in the most unexpected of places. These rogue planets, once seen as cold, dead wanderers, now stand as beacons of a new kind of cosmic hope, whispering the possibility that life, in its infinite forms, might truly be an unstoppable force, capable of blooming even in the profoundest darkness. They force us to redefine what it means for a world to be alive and to embrace a vision of the cosmos that is infinitely richer and more mysterious than our wildest dreams. The universe, it seems, is far stranger and more wondrous than we ever dared to imagine. It is not merely a collection of stable, star-centered families, but a dynamic, chaotic, and incredibly fertile environment where life might find a foothold in the most unexpected of places. These rogue planets, once seen as cold, dead wanderers, now stand as beacons of a new kind of cosmic hope, whispering the possibility that life, in its infinite forms, might truly be an unstoppable force, capable of blooming even in the profoundest darkness. They force us to redefine what it means for a world to be alive and to embrace a vision of the cosmos that is infinitely richer and more mysterious than our wildest dreams. But how? How could life possibly exist on a world cast out into the interstellar void, a world that has never known the warmth or light of a sun? For so long, our understanding of life has been inextricably linked to the star at the heart of our own system, the sun. We imagine photosynthesis, the green embrace of light, as the very foundation of all biological complexity. Yet the cosmos, in its infinite wisdom, offers a profound counter-narrative, a testament to life's tenacity that rewrites our most fundamental assumptions. This is where the story of rogue planets truly becomes mind-bending, where the loneliness gives way to an astonishing possibility. That these orphan worlds, far from being barren husks, could actually be cradles of a hidden, vibrant biology. Imagine for a moment, not a surface baked by stellar radiation, but a world cocooned in an impossibly thick atmosphere, perhaps hundreds of times denser than Earth's. This isn't just a gaseous blanket. It's a colossal thermal shield, a pressure cooker forged by gravity itself. Beneath this crushing, opaque sky, a phenomenon known to us on Earth as the greenhouse effect takes on an entirely new dimension. Here, the internal heat of the planet, generated by its own radioactive core and residual energy from its formation, has nowhere to escape. It's trapped, building up, warming the planet from the inside out. It was planetary scientist David J. Stevenson, a visionary from Caltech, who first theorized this astonishing mechanism in 1998. He proposed that a large rogue planet, particularly one with an atmosphere rich in hydrogen, the most abundant element in the universe, could create conditions for liquid water to persist on its surface. No sun, no photosynthesis, yet an entire ocean, warm and fluid, could exist. The pressure from such an enormous atmosphere would also play a crucial role, allowing water to remain liquid at temperatures that would otherwise cause it to boil away into space. This isn't science fiction. This is cutting-edge planetary science, a hypothesis that turns our ideas of habitability on their head. So, if a rogue planet can indeed harbor vast liquid oceans warmed by its own internal fires, the next, most thrilling question naturally arises. Could life emerge within them? And if so, What would such life look like? How would it survive without the lifeblood of sunlight? This is where we must cast our gaze, not to distant galaxies, but to the darkest, most extreme depths of our own home world. Our planet, Earth, is an astonishing teacher. For centuries, we believed that all life ultimately depended on the sun. The surface of our world, vibrant with green forests and sun-drenched oceans, reinforced this solar-centric view. But in the late 1970s, humanity made a discovery that shattered this paradigm. We plunged into the abyssal plains, miles beneath the waves, into realms of crushing pressure and absolute eternal darkness. There, nestled along volcanic rifts, we found something extraordinary. Entire ecosystems thriving around hydrothermal vents. These are not just isolated pockets of life. They are vibrant, bustling cities of biology, fueled not by sunlight, but by geological energy. Imagine towering chimneys spewing superheated, mineral-rich water from Earth's core. Around these black smokers, as they are called, you find communities of life that seem utterly alien. Chemosynthesis is the miracle that underpins these sunless ecosystems. Instead of converting light energy into sugars, as plants do through photosynthesis, these organisms convert chemical energy. They metabolize hydrogen sulfide, methane, and other compounds spewed from the Earth's interior, transforming these raw materials into the building blocks of life. This, then, is our profound aha moment. We don't have to invent hypothetical alien biology from scratch to imagine life on a rogue planet. The template for life, thriving in absolute darkness, under immense pressure, and fueled by the planet's own geothermal heart, already exists. The universe has already provided the instruction manual for life beyond the sun. So let us take this blueprint and project it onto our orphan world. Envision that cinematic journey, plunging through the crushing, opaque hydrogen atmosphere of a large rogue planet. The atmosphere is so dense, so vast, that it acts like a perpetual twilight, a never-ending dusk that absorbs any faint starlight that might penetrate its upper layers. As we descend, the pressure mounts, the temperature rises, until, after miles of descent, we finally break through a thick, miles-deep ice shell. It's a transition from one form of darkness to another, but with a profound difference. Below the ice, a vast liquid ocean stretches out before you, an entire world of water. This is not the frigid, lifeless void you might expect. Instead, it's a global sea, warmed by the immense geothermal engine of the planet's core. The blackness here is absolute, an eternal night that has never known a sunrise. But it is not empty. Imagine the seafloor, miles beneath the surface, studded with glowing geothermal vents. These vents are not just geological features. They are the pulsing heartbeats of this world, spewing forth the chemical nutrients that are the foundation of all life here. Around these vents, just like on Earth, vibrant ecosystems would flourish. You would see strange bioluminescent creatures, their bodies adapted to pressure and darkness, emitting their own eerie light to navigate, hunt, and attract mates. Imagine colossal translucent tube worms. This isn't just about rogue planets themselves. The cosmic generosity of these wandering worlds extends even further. Consider the possibility of rogue moons. Just as gas giants in our own solar system, like Jupiter and Saturn, host an array of icy moons, a large gas giant rogue planet could carry its own entourage of satellites. And on these moons, another potential cradle for life emerges. Tidal forces, the gravitational tug-of-war between a massive planet and its moon, could generate immense internal heat within the moon. This is precisely what happens with Jupiter's moon Europa, where tidal heating is believed to maintain a vast subsurface ocean beneath its icy crust. If a rogue gas giant carried such a moon, that moon, too, could harbor a liquid water ocean, warmed by the constant gravitational kneading of its parent planet. Life in such an environment would be even more deeply nested, a world within a world, warmed by a planet without a sun, in an ocean that has never seen a star. The implications are profound. If Stephenson's theory holds, and if the evidence from our own deep ocean serves as a reliable guide, then the galaxy's billions of orphan worlds are not merely cold, desolate rocks. They are potential havens, self-sustaining biospheres, carrying the potential for life through the vast, dark emptiness between stars. They challenge our very definition of a habitable zone. This revelation forces us to confront a deeper truth. Life, in its essence, is not solely dependent on light. It is an extraordinary phenomenon, capable of harnessing energy from the very fabric of its environment, whether it be the radiant embrace of a star or the fiery heart of a wandering world. This vision of fires in the deep, of glowing vents and bioluminescent ecosystems thriving in eternal darkness, is one of the most compelling and poetic possibilities in modern astrobiology, urging us to expand our imagination and truly appreciate life's incredible resilience. These rogue planets, these cosmic refugees, are not just lost. They are pioneers, forever redefining what it means to be alive. We've peered into the profound depths of rogue planets, those silent wanderers, and imagined the fires in the deep that could warm a sunless ocean. We've considered how a thick, insulating atmosphere, perhaps rich in hydrogen, could trap the geothermal warmth rising from a planet's very core. It's a vision that radically expounds our understanding of where life might emerge, pushing the boundaries of the habitable zone far beyond the comforting glow of a star. But what if the most extraordinary secret isn't on the orphan world itself? What if the best chance for life isn't found on these cosmic refugees, but with the children they took into exile, their moons? This is where the story deepens, where the loneliness of a rogue planet takes on a new, startling dimension of hope. Imagine, if you will, a gas giant, many times the size of Jupiter, not orbiting a star, but drifting alone through the galactic void. It is a world of unimaginable storms and crushing gravity, a titan of hydrogen and helium, eternally shrouded in an alien twilight. Yet, within its immense gravitational embrace, it holds a family of moons. And it is here, in this most unexpected of settings, that the potential for life might truly blossom. Think of this rogue gas giant not as a barren wanderer, but as a colossal celestial hearth, a gravitational furnace for its moons. Its sheer mass, its relentless pull, constantly kneads and squeezes the smaller worlds orbiting it. It's a cosmic dance of immense power, a perpetual tug-of-war that generates a profound internal heat within these captive satellites. This isn't the gentle warmth of sunlight. It's the raw, visceral heat, born from friction, from the very bending and stretching of rock and ice. Just as Jupiter's colossal gravity relentlessly deforms its moon Io, so too could a rogue gas giant transform its moons. The science behind this is both elegant and awe-inspiring. As a moon orbits its massive parent, the gravitational forces exerted on it are not uniform. The side of the moon closest to the rogue planet experiences a stronger pull than the side farthest away. This constant flexing, this ceaseless internal motion, generates immense friction deep within the moon's core and mantle. It's a process called tidal heating, and it's a powerful engine of warmth, capable of keeping a moon's interior molten. On such a moon, shielded from the direct vacuum of space by a potential ice shell hundreds of miles thick, a vast global ocean could exist. This would be an ocean unlike any we typically envision, one that has never known the light of a star. Instead, its warmth would come from below, from hydrothermal vents on the seafloor, spewing mineral-rich, superheated water into the frigid depths. These vents would create vibrant, chemosynthetic ecosystems, oases of life thriving on chemical energy. We see echoes of this possibility right here on Earth, in the abyssal plains where life flourishes around hydrothermal vents, entirely independent of the sun's distant rays. It's a testament to life's adaptability, its profound ability to find and harness energy in the most extreme environments. Consider the discovery by the James Webb Space Telescope in the Orion Nebula, the revelation of Jupiter mass binary objects, or jumbos. These are pairs of rogue planets orbiting each other, completely unbound to any star. This astonishing finding challenges our existing theories of planet formation. If rogue planets can form in binary pairs, then the concept of a single massive gas giant rogue with its own retinue of moons becomes even more plausible. The sheer scale of this possibility is mind-boggling. Estimates suggest there could be billions, perhaps even trillions, of rogue planets wandering our Milky Way galaxy alone. If even a fraction of these possess moons, the number of potentially habitable worlds could be far greater than we ever imagined. It's a cosmic lottery where the winning tickets aren't just planets orbiting stars, but also the children of these sunless wanderers, kept warm by the constant embrace of their exiled parent. Imagine a journey plunging through the thick, crushing hydrogen atmosphere of one of these rogue gas giants, then breaking through a miles-thick ice shell of its moon, and finally emerging into a vast, dark liquid ocean. Below, glowing geothermal vents illuminate alien ecosystems. Bioluminescent creatures drift through the currents, and the rhythmic pulse of tidal forces echoes through the water. This isn't science fiction. It's a scientifically grounded hypothesis. The universe, in its infinite complexity, seems to delight in surprising us. The idea that a moon could be a more robust incubator for life than its larger parent planet is a profound paradigm shift. The rogue planet provides the gravitational engine, the steady internal heating mechanism, while the moon itself offers the stable environment for liquid water. It's a symbiotic relationship born of exile, a testament to the enduring power of gravity and the astonishing resilience of life. The Nancy Grace Roman Space Telescope, set to launch by May 2027, promises to be a game-changer. Designed with gravitational microlensing as a key mission, it is expected to be 10 times more sensitive, capable of detecting hundreds, if not thousands, of Earth-mass rogue planets. The European Space Agency's Euclid telescope, launched in 2023, has already begun identifying numerous new rogue planet candidates in the Orion Nebula, further confirming that we are on the cusp of an observational revolution. We are moving from theoretical possibility to tangible discovery, charting the demographics of these hidden worlds, and perhaps, one day, even detecting the subtle signatures of their tidally heated moons. The galaxy, then, is not merely a collection of stable families, of stars with their neatly orbiting planets. It is a vast diaspora, a cosmic oceans teeming with wandering worlds, many of which carry their own families, their own children, into the eternal night. And within the cold, dark embrace of these gravitational furnaces, life might be quietly, patiently waiting to be found. It's a universe more intricate, more vibrant, and far more filled with potential than we ever imagined. The journey of these orphan worlds continues, and with them, the boundless promise of life itself. The galaxy, then, is not merely a collection of stable families, of stars with their neatly orbiting planets. It is a vast diaspora, a cosmic ocean teeming with wandering worlds, many of which carry their own families, their own children, into the eternal night. And within the cold, dark embrace of these gravitational furnaces, life might be quietly, patiently, waiting to be found. It's a universe more intricate, more vibrant, and far more filled with potential than we ever imagined. The journey of these orphan worlds continues, and with them, the boundless promise of life itself. But just when you think you've begun to grasp the profound solitude of these rogue planets, just when you've started to wrap your mind around the idea of a single sunless world adrift in the cosmic ocean, the universe, as it so often does, throws another astonishing curveball. It's a discovery so baffling, so utterly unexpected, that it compels us to re-examine, and perhaps even to rewrite, our fundamental rulebook for how planets and even stars are born. It's a cosmic riddle, etched into the very fabric of one of the most iconic star-forming regions in our galaxy. Imagine, if you will, looking into the very heart of creation, a celestial nursery where new stars ignite and nascent planetary systems begin their slow, majestic dance. We're talking about the magnificent Orion Nebula, a breathtaking spectacle visible even to the naked eye as a fuzzy patch in the sword of the constellation Orion. But through the eyes of the James Webb Space Telescope, this familiar beacon transforms into something far more profound. With its unparalleled infrared vision, the JWST can pierce through the obscuring veils of gas and dust, revealing the hidden processes of stellar and planetary birth. It was here, amidst this vibrant, chaotic tapestry of creation, that in 2023, Webb made a discovery that has sent ripples of bewilderment and excitement through the astronomical community. The Webb telescope peered deep into Orion, not just seeing the brilliant young stars that dominate the visible spectrum, but detecting the faint, cold embers of something else entirely. Dozens of objects glowing weakly in the infrared, floating freely, without any apparent gravitational connection to a parent star. But these weren't just the solitary rogue planets we've been discussing. No, what the Webb telescope found were pairs of these orphan worlds, locked in a delicate, almost improbable gravitational dance with each other. They've been christened Jarumbos, Jupiter mass binary objects. Take a moment to truly absorb that. Not just a singular wanderer, adrift and alone, but two cosmic orphans, holding each other close, so to speak, as they journey together through the vast, cold interstellar void. These jumbios are substantial, with individual masses ranging from about 0.7 to 39 times that of our own Jupiter. And their separations are truly immense, stretching from 28 to an astonishing 384 astronomical units. That's 28 to 384 times the average distance between Earth and our Sun. To put that in perspective, Neptune, the outermost major planet in our solar system, orbits our Sun at approximately 30 astronomical units. So, many of these binary pairs are often incredibly far apart from each other, yet still intricately, gravitationally bound. They are, in essence, tiny, isolated solar systems, with two planets as their only members, lost in the cosmic wilderness. This discovery is more than just interesting. It is a profound cosmic riddle, a truly perplexing puzzle left for us in the heart of the Orion Nebula. It's not simply a new type of celestial body. It's a new class of object that fundamentally challenges everything we thought we knew about planet formation, and indeed, about the very early stages of star birth. Our current understanding of how rogue planets come into being generally falls into two main, well-established camps. The first, and perhaps most dramatic scenario, posits that rogue planets are born within the tumultuous embrace of a fledgling solar system. During the chaotic cosmic billiards of a young system's gravitational interactions, massive planets, like a migrating Jupiter, can act as colossal slingshots, flinging smaller, less massive worlds out of their home system entirely. These ejected planets become the solitary wanderers, cast out into the eternal night, carrying the frozen memory of their birth. This is a violent, singular event, a brutal send-off into isolation. The second scenario suggests that some rogue planets form in isolation, much like stars do, collapsing directly from a cloud of gas and dust. These are often called sub-brown dwarfs. In this model, a gas cloud simply doesn't accumulate enough mass to ignite the nuclear fusion in its core that would make it a true star. Instead, it forms a massive self-luminous object, but one that is still far larger than any gas giant planet. Jumbios, with masses between 0.7 and 13 Jupiters, are significantly less massive than even the smallest brown dwarfs. They occupy a strange in-between realm, too small to be typical sub-brown dwarfs, yet too massive and too paired to be easily explained as ejected planetary siblings. But Jumbios, these mysterious Jupiter mass binary objects, don't fit neatly or comfortably into either of these well-defined narratives. This is where the profound mystery truly deepens. Consider the ejection scenario. If these jumbos were indeed violently ejected from a nascent planetary system, how did two massive planets manage to get kicked out together and somehow remain gravitationally bound to each other, often with such wide separations? The chances of that happening seem astronomically improbable, almost impossible under current models. The energy required and the precise alignment needed for such an outcome defy our understanding of these gravitational instabilities. Now, let's look at the direct formation scenario. If they formed in isolation, like miniature stars that never quite lit up, why are they so small? As we noted, objects that form directly from the collapse of gas clouds typically grow to be much larger, becoming brown dwarfs. The conditions for forming two such low-mass objects directly from a collapsing gas cloud and having them remain gravitationally bound at such wide separations are simply not accounted for in our current theoretical frameworks. This is the universe, reminding us with a wink and a cosmic shrug that our neat theories are often just starting points, mere approximations of a reality far more complex. It's like finding a pair of lost children, hand in hand, wandering through a vast, untamed wilderness when you expected to only encounter solitary travelers. The implications are staggering. If these jumbios are common throughout star-forming regions, if the Orion Nebula is not an anomaly, but a typical snapshot of a widespread phenomenon, then the galaxy might be even more densely populated with free-floating objects than we previously thought. It means our census of rogue planets, already estimated in the billions, might need a significant upward revision. These unexpected discoveries from the James Webb Space Telescope, along with the ongoing work of missions like the European Space Agency's Euclid telescope, which in 2024 confirmed numerous new rogue planet candidates in the Orion Nebula, are painting a vivid picture of a galaxy that is far more dynamic, far more unpredictable, and far more filled with surprises than any textbook could convey. This is the thrill of cosmic exploration, isn't it? The constant push against the boundaries of our knowledge, the willingness to admit we don't yet know, and the insatiable curiosity to find out. If you're finding this journey into the unknown as exhilarating as we are, and if concepts like these expand your sense of wonder and challenge your perception of reality, show your support with a like. It truly helps us continue these explorations and bring more of these cosmic enigmas to light. The jumbios are a profound testament to the universe's endless capacity for wonder. They are a cosmic riddle, yes, but also an invitation. an invitation to rethink, to reimagine, and to push the very limits of our understanding. They are a poignant reminder that even in the vast, cold expanse between the stars, companionship, in some form, can exist. And perhaps, just perhaps, life, too, finds its way, even when the rules are broken, even when the path is unimaginable. The dance of the orphan pairs has just begun, and we, as curious observers, are privileged to witness it, eager to uncover the next piece of this grand cosmic puzzle. From the unexpected companionship of the jumbos, those dancing orphan pairs in the Orion Nebula, we learn that the cosmos holds an endless capacity for wonder, a readiness to break the rules we thought we knew. We've seen how life, in its most tenacious forms, might cling to existence in the crushing depths of a rogue planet's sunless ocean, warmed by the planet's own internal furnace. We've peered into the possibility of life, thriving on a rogue moon, kept liquid by the relentless tug of its massive parent. These stories challenge our most fundamental assumptions about where and how life can take root. They invite us to rethink, to reimagine, and to push the very limits of our understanding of what a home truly is. But what if these lonely wanderers, these cosmic exiles, have an even grander, more profound purpose? What if their true role isn't just to be a home, but to spread it? Imagine for a moment the galaxy not as a collection of isolated, stable families, but as a vast, interconnected ecosystem. In this cosmic garden, rogue planets aren't just forlorn debris. They are, quite possibly, the universe's most extraordinary, most resilient seed-bearers. They are the galactic pollinators, carrying the potential for life across the immense, silent stretches of interstellar space, like microscopic spores caught on the cosmic wind. This idea, as mind-bending as it sounds, is rooted in a fascinating scientific hypothesis: panspermia, the theory that life, or its building blocks, could travel between celestial bodies. On Earth, we know of extremophils, tiny, incredibly tough microbes that can survive conditions we would consider utterly lethal. Some can endure extreme cold, radiation, and even the vacuum of space, entering a dormant state, awaiting more favorable conditions. Now, picture these hardy travelers, perhaps nestled deep within a subsurface ocean of a rogue planet, or frozen solid within a comet-like chunk of ice that was once part of its crust. When a rogue planet is violently ejected from its birth system, it carries with it not just its own geological history, but potentially a frozen living memory of that system. Perhaps it scooped up some primitive microbes from a primordial ocean, or captured organic molecules from a passing comet. Encased in ice, or protected by a thick, insulating atmosphere and a deep ocean, these microscopic passengers could endure the millennia-long journey through the frigid abyss between star systems. The journey would be impossibly long, impossibly cold, and impossibly dark. Yet, for dormant extremophils, time and cold are not necessarily death sentences, but merely pauses in existence. Then, after untold eons of solitary wandering, our rogue planet, this lonely seed-bearer, might encounter another nascent planetary system. Perhaps it gets gravitationally captured, becoming a new eccentric member of a foreign stellar family. Or maybe it simply makes a close pass, its gravitational pull slinging off ice-rich fragments, or even shedding parts of its atmosphere, that then fall into the gravity well of a new young star and its forming planets. In this cosmic exchange, the rogue planet could, in effect, pollinate the new system, delivering its ancient, frozen cargo of life's building blocks, or even dormant organisms themselves, to fresh, fertile ground. Could these lonely wanderers, which we have come to see as cosmic exiles, actually be the unifiers of the galaxy? Is their true purpose not to be a permanent home, but to spread it, to act as silent, unwitting vessels, ferrying the very essence of existence from one corner of the cosmos to another, ensuring life's tenacious grip on reality is not confined to a handful of isolated sun-warmed pockets. It's an aha moment that flips our entire perspective. The universe isn't just expanding, it might also be exchanging. It might be breathing life across the void, carried on the backs of these unassuming dark worlds. This isn't just poetic speculation. It's a frontier of astrobiological thought. And as our technology advances, we're moving closer to confirming the sheer abundance of these cosmic nomads. The hunt for these unseen worlds is intensifying, shifting from rare serendipitous discoveries to systematic wide-field surveys. Enter the Nancy Grace Roman Space Telescope, NASA's next-generation observatory, set to launch by May 2027. This incredible instrument will be a game-changer in our quest for rogue planets. Roman is designed to be 10 times more sensitive than current ground-based microlensing surveys, and it's expected to discover hundreds, perhaps even thousands, of Earth-mass rogue planets. Think about that. A detailed census of worlds just like our own, wandering the galaxy freely. This telescope will revolutionize our understanding of their demographics, giving us a clearer picture than ever before of just how numerous these mysterious objects truly are. It will transform the concept of rogue planets from a theoretical possibility to a tangible, observable reality, mapping out a hidden population of worlds that silently drift through the galactic night. And Roman won't be alone in this cosmic detective work. The European Space Agency's Euclid telescope, which launched in 2023, has already begun to demonstrate its power. Its initial scientific results in 2024 have confirmed the existence of numerous new rogue planet candidates, particularly in the Orion Nebula, the very region where the enigmatic jumbos were first spotted by the James Webb Space Telescope. Euclid's wide-field surveys are opening a new era, painting a more complete picture of our galaxy's hidden inhabitants. These missions are not just about counting distant dots. They are about understanding the fundamental processes of planetary formations and evolution, and perhaps the very mechanisms by which life itself is distributed throughout the universe. They are about moving from theory and singular events to a rich, diverse catalog of actual discoveries. The implications are staggering. If life can indeed emerge and persist on these sunless worlds, and if these worlds can then act as carriers, the cosmos becomes a far more vibrant, interconnected, and alive place than we ever dared to imagine. The seemingly empty spaces between stars become highways for life, traversed by billions of silent, dark vessels. It's a staggering thought, isn't it? The universe, in its infinite complexity, constantly finds ways to surprise us, to challenge our anthropocentric views, and to expand our sense of what is possible. If concepts like this expand your sense of wonder and make you look at the night sky with a renewed sense of awe, show your support with a like. It truly helps us continue these explorations and bring more of these cosmic enigmas to light, sharing them with a community of curious minds like yours. So, as we look to the future, to the data that Nancy Grace Roman and Euclid will soon deliver, we stand on the precipice of a profound revelation. These telescopes won't just find cold, dark rocks. They will unveil a vast, hidden population of cosmic wanderers, each with its own untold story, its own potential for life, and its own silent, ongoing journey. And with each discovery, the question deepens. What is the ultimate cosmic role of these billions of orphan worlds? Are they truly just lonely exiles, forever lost in the dark? Or are they the universe's most enduring, most widespread couriers, carrying the fragile, precious seeds of life from one star-kissed cradle to the next? Could the very emptiness of space be teeming with these dark pilgrims, ensuring that the dance of life, once it begins, never truly ends? The questions these rogue planets raise are not just about astronomy or biology. They are about our place in a universe far more dynamic and interconnected than we ever dreamed. They are about the enduring mystery of existence itself and the countless ways it finds to persist, to thrive, and perhaps to travel. We are only just beginning to understand the true nature of our galactic home and the silent, drifting worlds that populate its vastness. If you've journeyed with us through the chaotic
From the
birth of
rocket
solar
ship to
systems,
the
the
swirling
ghost-hunting
galaxy,
science of
our
microlensing,
path has been
the
long.
incredible possibility of
We've
life in
explored
sunless
vast
oceans, and now to the idea of these cosmic seed-bearers, then you're a true explorer of the unknown. We are just scratching the surface of celestial enigmas, and there's so much more to uncover. Join our community
subscribe
of
button
cosmic
and ring the
adventurers.
bell
Make
icon
sure
for
you're subscribed to
notifications.
Celestial
And
Enigmas
be sure
and
to
have
leave a comment
notifications
down
turned on
below.
so you don't miss our next dive into the universe's most captivating mysteries. And what are your thoughts? Do you believe these rogue planets could be carrying life across the stars? Share your theories, your awe, and your own sense of wonder in the comments below. Let's explore these profound questions together.